Unit 8 starts off with a bit of static electricity, and it's explained in detail why this happens. A positively charged plastic rod and when rubbed with a duster. In your answer you should mention the effect it has on the duster. So any object becomes charged because it either gains or loses electrons. Here we've got a plastic rod which is rubbed with a duster. It becomes positively charged, therefore the plastic rod has lost electrons. Where have the electrons gone? They've gone onto the duster becomes negatively charged. So explain in detail why this happens, and your answer should mention the effect it has on the duster. So the plastic rod loses electrons when rubbed by the cloth. And the cloth gains electrons. Now, whenever you rub a cloth and a plastic rod together, the friction between them creates heat. The heat then provides enough energy to transfer the electrons. So the electrons are transferred from the plastic rod to the cloth, and that leaves the cloth negatively charged and the rod positively charged. So the rod is positively charged, and the cloth is negatively charged. And with quality of written communication there, make sure you write sentences and make sure you start with capital letters, your spelling is correct, and punctuate properly. All right. When John walks across a carpet and touches a metal door, we're still on static electricity here. A small spark passes between John and the door handle. Explain in terms of movement of electric charges what is happening. Well, the only electric charges that move are the electrons, so electrons have jumped from John to the door handle. The door handle is likely to be metal and is then connected to earth, so the electrons have earth themselves. Similar calculation then to we had in last year's paper, in terms of we have a spark 0.2 seconds producing a current, and this time the current is 40 microamps. So again, alarm bells should be ringing here, 40 microamps. Now, I think the easiest way to write 40 microamps is to say that's equal to 40 times 10 to the minus 6 amps. But you need to be good at your indices in order to do that. An alternative way of writing that is to say that's equal to 0. And then that's equal to 0.0004 amps. Calculate the electric charge. So again, the equation we use is Q equals IT. Therefore, that's equal to 40 times 10 to the minus 6 times 0.2 seconds, and that's equal to so 40 times 10 to the minus 6 right, so that's equal to 8 times 10 to the minus 6, which is equal to 8 microcoulombs, or 8 times 10 to the minus 6 coulombs. Now you could write that as 0.000008. That's 8 with 5 zeros in front of it, 0.0, and there's 5 zeros and then the 8, and that would be the same answer. But again, here you've got only 4 marks this time, but there is a coulomb in there, and the 40 microamps, the difficulty changing that from microamps into amps, again, that's been tested there, and that's something you need to look out for in your papers. Alright, question 4 is again a circuit diagram. We can see we now have still two resistors in series. We've got a voltage and we've got resistances, which will allow us to work out a current. When the switch is closed, what will be the reading on the ammeter? Well, when we close the switch, we have two 4 ohm resistors in series with a 12 volt battery. So the total resistance is equal to 4 plus 4, which is equal to 8 because they are in series. Therefore, I is going to be equal to V divided by R, which is equal to 12 divided by 8, which is equal to 1.5 amps. So we have 1.5 amps coming around the circuit. When the switch is closed, what will be the reading on the voltmeter? Well, the voltmeter, okay, is in parallel across a 4 ohm resistor. So what we're going to look at here is we're going to say, well, V equals IR for this, and if V equals IR, then that means that V is equal to, we've just worked out the current to be 1.5, so V is going to be equal to 1.5 times the resistance, which is 4. So fill it in just in the space that we've got. V equals IR becomes V equals 1.5 times 4, so V is equal to, well, 4 times 1.5 is going to be equal to 6, so that voltmeter reads 6 volts. And if you look at this circuit diagram, you can see we have 6 volts across here. We will also have 6 volts across here, giving us a total of 12 volts, and that's because we have 4 and 4 in series, so they get equal shares of the voltage. 4 ohms takes 6 volts, 4 ohms takes 6 volts. Remember, the bigger the resistor, the bigger the share that it gets.